And good afternoon, colleagues. Our research is aimed at developing effective ways to regulate the function state of plants under stress. I think you saw my presentation, and a humid subtropical zone of Russia is favorable for the cultivation of subtropical crops. Mild winter, the average daily temperature reach +6, +8 degrees C, a long growing season from March to November. It's no accident that in the Sochi area, such crops as a variety of citrus fruits, persimmons, kiwi, etc., grow in the open ground. But the main value is a tea plantation. But the thermal regime has changed. The year with an absolute minimum -6, -10 degree on the coast have become more frequent. Precipitation has become less, and the main limited factor for tea plants are low air temperatures in the winter and early spring period, high temperature in the summer months. This leads to a decrease in productivity and quality indicators. We believe that increase the frost resistant and drought resistance of tea is possible. It's possible by using a number of innovative forms of fertilizer and plant growth regulation. And the object of the study are tea plants of common variety population. You can see a scheme our researchers. The following agrochemical were used: rocogumine, sodium humat, bombardier, and control it's a foliar water spraying. Rocogumine is a complex of amino acids with the additions of humid, fulvic acid, and trace element. Bombardier is a complex of biosimulations, amino acids, polysaccharide, and biofertilizers. Rocogumine and bombardier, it's a innovative form fertilizers and plant growth regulator too. The size of the experimental plots is 8 square meters, and the experiment is repeated 3 times. Foliar spraying was carried out 3 times. At the beginning of the growing season, usually it's the second decade of May, after the second wave of growth tea plantation, usually it's the first decade of July, in the second decade of November, in preparation for the winter dormancy period. And laboratory researches were conducted during 4 years, from March to November. And during the period of stress, plants tend to accumulate reactive oxygen species. At the same time, we observed an inhibitor of enzymes activity as the air temperature increased. And activation enzymes to increase plant resistance is an important task. And we noted that the catalase activity significantly increased in the variants with treatment. Consequently, the plant protection processes are activated too. Another defense adaptive mechanism is an increase in bound water in cells during drought. You can see in variant with foliar spraying, there is a significant increase in bound water. This activates the assimilance process and increase an amount of dry matter in the leaves. More active formation of proline in the leaves was noted. it can be interpreted as active process associated with the inclusion of mechanism of non-specific protection of plants, of tea plants. The content of ascorbic acid increase, which indicate increase in the natural value of raw materials, because tea plants, it's a raw materials for tea extract. Significantly increase the content of tannin. Tannin, it's an indicator associated with both plant resistance and leaf quality. Ensure the optimal function state of plants during a stress period leads to the activation of productivity process and increase the productivity of the tea plantation. And you can see in the second year, the difference with the control is more significant. We can see the use of fertilizer and plant growth regulation can become the main elements of tea cultivated technology. Treatment optimize the adaptive potential of tea plants, regulate their productivity, and increase natural value of the raw materials. And as a conclusion, you can see that our research is a very important task at the Russian Federation. And thank you for your attention.